the expected value. So what we're going to do next is I'm going to click on, okay, and we went out, did we go over standard deviation of discrete? I think we went over that too, so I don't have to, and remember, you're supposed to use this formula, not this one, okay? I can't write on it, but we're going to just use this formula right here. We've already used that. That's finding the standard deviation. I think we did that with y'all, didn't we, Miss Carter or Miss Phillips? Didn't we do the standard deviation of a, I think we did the mean and the standard deviation.
Yes.
Okay. All right. So, and here was an example. I'm not going to go through that example. I know what, and this is what we did, but we did it on the Excel spreadsheet. So you should be able to do that. Make sure you can find the mean and the standard deviation of a frequency distribution or a polynomial, binomial, or whatever they want to call it, a probability distribution. And I think the next thing we're going to go over is a binomial experiment. Okay, binomial experiment is when you have a fixed number of trials, meaning I flipped a coin 15 times, or I counted 10 households on a survey. I've got a fixed number of trials. That's one test. The trials are independent. The first one does not affect the second one. So if I flip a coin up in the air and I get heads and I pick it back up, heads don't disappear, and I just have tails. You still have heads and tails so they're independent, meaning that the flip that you just flipped doesn't affect the future flip. Okay, so the trials are independent. For each trial, there is two outcomes, heads or tails. And the probability of success is fixed for each trial of the experiment. That's true. I'm either going to get a head or I'm going to get a tail. Now this is where we're going to do the NPX. All right. And let me go back one, and I'm going to highlight, and I'm going to move this over a little bit because I'm going to write something on the board, and I hope you can see it, Miss Carver. This is where I'm using the my document cam, and I don't know if you're going to be able to use it, or see it. There may be a delay. Just let me know if you see it. Should be right there. Anyway, I'm trying to do the best I can here. This is where we're going to be using NPX. And NPX is what we're going to use in the calculator. And I'm going to have to get a downloadable calculator on this. I don't know how I'm going to do it because this is my home computer and I'm able to use the monitor and the document cam. But if I use my office computer, I can't plug in all this stuff, and it just doesn't, I'm not able to do it, but I got to find a calculator. Anyway, NPX, and you're going to type it in that order. Also, the complement of P is Q. Now, you're not going to need it, but when you're doing the formula that I'm going to show you in just a minute, you're going to use Q. You don't have to because you're using the calculator. And on the calculator, you're going to use second, bars, and then you're going to use, there's two of them, binomial PDF and binomial CDF. And I'm going to explain those two in just a minute. Okay? Now, this is where you have a fixed number of trials, and I'll give you an example. You flip a coin 10 times. And 6 times, it comes up heads. What is the probability if you flip the coin another 8 times? What is the probability of heads if you flip a coin another 8 times? And the way that happens is n is equal to 10 because it's your biggest number. P is equal to 6 out of 10, which is equal to 0.6. And X is equal to 8. And you would punch it in your calculator. All right, that's where we're going with this. So let me get back to the slide. And I wish you could see some of this, Miss Phillips. I hate it. That just bothers me. I don't know why Miss Carver can see it, but you can't. Oh, well. And we're going to get down here. And there's Q right there. Let P denote the probability of success so that Q, which is 1 minus P, is the probability of failure. So N, P, and X. X has to be less than N. Okay, you can't say, what if you flip a coin another 20 times? It doesn't work that way. Okay, and they're probably going to show you here in the next. There's an example right here. A player rolls a pair of die, rolls a pair of fair die 10 times. The number X of 7s rolled is recorded. And that we don't have to figure it. That's a binomial experiment. Why is it binomial? Because a fixed number of times. There's only 2 outcomes. Each one's going to throw out a number. And it has, they're asking you what about 7 times? 7 is below 10. So that is a binomial experiment. This is not a binomial experiment because it's not talking about a fixed number of trials. It says 11 airlines. Well, 11 airlines is nice, but that's not a fixed number of trials. Okay? So I can see now. Okay, good. Do you know what happened? Did anything happen? Miss Phillips, can you see anything? She probably left. I don't blame her.
No, sir, I can't see.
Okay. Well, I don't know what's wrong, Miss Phillips. I'm irritated, but I don't know what's wrong. I wish I did. It's just slow. Okay. All right. Well, I'll try to go slow while I'm doing the slides. I'm trying to get y'all through this. I'm trying to give recordings to other students to get us through this mess. That's what we're trying to do right now. So just bear with us. So this is not a binomial experiment because it's not a fixed number of trials. 11 large airlines, that's not a flipping of a coin or a rolling of a die. Okay? And we're going to do a problem here in just a second. In a class of 30 students, 55 are female. The instructor randomly selects 4 students. The number of X of females is recorded. You can't vote twice, okay? When you're talking about bodies or votes, you can't go back and say, oh, I'm going to be on this committee, but I'm going to go back and be on the other committee. You can't do that, all right? That's why the numbers are not independent. Okay. Oh, I'm not going to do that because I'm going to construct a probability distribution by hand, and I'm going to do it with the whiteboard, with the document cam. So I'm going to get out of this, and I'm going to pull up the document cam, and here's the document cam. Hopefully, can you see that, Miss Phillips? The document cam?
No, sir.
I don't understand. Miss Carver, can you see the document cam? It may be slow, but I'll just wait until you type it in. Hopefully it'll show up. I didn't know there was such a lag. Okay, so, not yet. Dang. All right, so there's a lag. I didn't know there was a lag. Okay, so hopefully there's not a lag on the recording. I hope there's not. I'm going to give you an example. Let's say that I work at a fertility clinic, and we have found that the probability of a girl being born is equal to 0.52. And the probability of a boy would be 0.48. Okay, that's given. And the directions are: construct a probability distribution with 3 children. Okay? This is where you have to bring up the boy, 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 girl, girl, girl. You know, that what I told y'all at the beginning of the semester that y'all might want to, you know, write down. Okay? I'll see if I can do it right quick. Boy, boy, boy. Boy, girl, boy. Boy, boy, girl. Let's see. Boy, girl, boy, boy. And then I have girl, girl, girl down here. And girl, boy, girl. And girl, girl, boy. There should be 8. And girl, or boy, girl, girl. Does that make sense? All right. Now, y'all check me and make sure I got them all down there. Now, what you got to do is you got to construct a binomial or a distribution, and this is the event. The event is, and we'll say 0 girls, 1 girl, 2 girls, and 3 girls. Okay, the probability of that event, well, we got to calculate it, so I'm going to put 2 or 3. So here, this is going to be the probability of the event. Well, how many 0 boys do we have, or 0 girls? Okay, there's 1 0 girl, and that's boy, boy, boy. So that's boy, boy, boy right there. And then this is 3 girls. That's girl, girl, girl. And then in the middle, you got one girl. 1 girl would be here, and 2 girls would be here. That's 1 girl, and 2 girls would be here. So here we've got boy, girl, boy, boy, girl, boy. We've got boy, boy, girl, boy, boy, girl, and we've got girl, boy, boy. And here we got boy, girl, girl, boy, girl, girl, and we've got girl, girl, boy, and we've got girl, boy, girl. And now we've got to calculate that. Probability of E calculated. Now, I'm not going to ask you this on a test, but you will have to construct one like on a real small one on a standardized test or a homework problem. But I'm not going to ask you this on a test. I'm just going to show you how to construct a. Now here, we've got 3 boys. The probability of a boy is 0.48. So that's going to be 0.48 to the 3rd power. And this is going to be 0.52 to the 3rd power. I want you to take your calculators. Well, I'll do it because one of y'all can't talk and the other one can't see. So I'll do it on my calculator. So that's going to be 0.48 to the third power. 0.48 raised to the third power. I got, parentheses, 0.1106. 0.1106. And this is the probability of the event happening. And then 0.52 to the third power. 0.52 y to the x, or x to the y, 3, close parentheses, 0.1406. And now, here, I'm going to go 3 times, let's say 0.52 to the second power, times 0.48 to the first power. Okay, so that's going to be 3 times, I'm going to do 0.52 raised to the second power, oops, I'm sorry, to the first power, 48 to the second power, that's 2 boys. Sorry, let me redo that. 0.48 raised to the second power times 0.52 equals times 3. I got 0.3594. 0.3594. And then the third one has got 2 girls, so that's going to be 3 times 0.52 to the third times 0.48. So 0.52 raised to the third power, or second power, sorry, times 0.48 times 3. 0.3894. 0.3894. Now, all 4 of these are between 0 and 1. And if you add all these up, what would you get? Well, let's see. 0.3894
Priority 1 message
plus
coming in on secured channel.
0.3594, 0.3594 plus 0.1106 plus 0.1406. And that's equal to 0.9999, which is equal to 1. Okay? That's how you construct a probability distribution. Can you see it now, Miss Carver? Hopefully you'll be able to see it before I move the paper. Okay? All right, so that's how you construct a probability distribution. Now, what if they ask you about a probability? Yeah, still lagging. There's nothing I can do about that because I live in BFE and our wireless, all our wirelesses are different. So, like I said, as long as I show you as much as I can, then y'all can do the problems and get the homework done. All right, so there's our example of doing, I'm not going to do this one because this one is more complicated because I did the tree, and I'm not going to ask you that on homework, but you know, you can find this. This is just like the 4 coins. If you look at this problem, the 4 coins is the same thing. So you can just substitute the 4 coins. Okay? Why do we multiply by 3? The reason we multiply by 3 is because there's 3 instances. Hold on. The reason we multiply by 3 is there's 3 instances to where there's two children or 1 children. Hold on. I'll take my blue marker. See, there's 1 instance, there's 2 instances, 3 instances. 1 instance, 2 instance, 3 instance. So that's where the 3 comes from. Okay? Hopefully that'll answer your question. Okay, good. All right. So, let me go back to the handy dandy PowerPoint. and get to a question that you're going to see on the test. Okay, here we go. This is and if you follow along, I don't know if you can follow along with your book, if you have a book or your text online, Miss Phillips. This is called the binomial probability distribution function. Now, you don't have to memorize this, but I'll write it, everybody can see it, should be able to see it. P of x is equal to combination ncx times p to the x power times q to the n minus x power. And that is a pain to do, so we don't do that. If we want to find, and I'm gonna go to the whiteboard again, not to the whiteboard, but to the document camp. If we want to find a function, if they give us NPX question, one thing I told y'all at the beginning of this section is whenever you're given a problem, you need to graph it on a number line. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Because the question may ask you exactly 4. Okay? If it asks you exactly 4, I'm just going to put a little dot at 4, then that means I've got to use second, vars, and I'm going to use binomial PDF. Okay, we're going to take our blue marker, exactly is PDF. Okay, meaning that you want exactly 4. What is the probability of 4 flips coming up tails, or 4 flips coming up heads, or whatever the case may be? They may give you n is equal to 7, n is equal to 10, p is equal to 0.3, and then x is what and then in this case, they're going to say, what if x is exactly 4? Okay? And I'm going to get another color. I'm giving you the 3 type questions that you might be asked here. Okay? One is exactly. The other one is going to be at most 3. Well, what does at most 3 mean? Well, we went over those slogans and sentences at the beginning of this section. At most 3 means that your highest number is what? Highest is 3. So that means I need to do 3, 2, 1, and 0. Now the way that you would do that in your calculator, you'd still have n is equal to 10.3 because that's what's given. And then you would say second, vars, binomial, CDF. And the C stands for cumulative, meaning that you're reading all of these to the left of 3. That's what binomial CDF means. Okay? And then you would type in 10.3 and 3, and it would give you, we're going to do an example here in just a second. And then in orange, at least 4. At least 4 means that the lowest number is 4. Okay? I'm sorry. Means the lowest number is 4. And if I give you the lowest number is 4, What is wrong with this thing? Hold on a second. I think I hit my... There we go. If the lowest number is 4, then that means I've got to do this one, this one, this one, and this one. Now, there's a hard way to do this and an easy way to do this. The hard way is to do NP4 plus NP5 plus NP6 plus NP7 using binomial PDF. Okay? Okay, using binomial PDF, you would do that 4 separate times. And you would type in, well, you'd only have to do it 3 because you got exactly 4 with the first one. And then you'd have to type in 10.3 and 5, get that one, then 10.3 and 6, and that's, or you could get the complement of the green. 1 minus the complement of the green. And that's another way. And you're going to see this in just a minute. Okay? So those are the 3 type problems that you're going to get. Okay? So, let's look at the problems that they're going to give us. And oops, there's the, and I'm not going to spend a lot of time on this. At least, or no less than, or greater than or equal to, more than or greater than, fewer than or less than, no more than, or at most, or at least, or at, or less than equal to, exactly or equals. Those are the slogans or the words. I think we went over those at the beginning of the section. 6.1, I think we went over those. Okay? Here's an example. According to Experian Automotive, 35% of all car-owning households have 3 or more cars. In a random sample of 20 car-owning households, what is the probability that exactly 5 have 3 or more cars? Okay, so I'm going to leave that up on the board. I'm going to exit out of there, and I'm going to see if I can bring in the, there's that, and then I'm going to bring in the, there we go. And I know it's kind of hard to see, but I'm trying to do 2 things at one time here. So it says, according to Experian Automotive, 35%. Well, there's P right there. So in this problem, N is equal to 20. P is equal to 0.35. Therefore, Q is equal to 0.65. And in this case, X is equal to 5. Because the question says, what is the probability that exactly 5 cars? So you're going to type in NPX. So this would be second, vars, binomial, PDF, and then in old calculators, it's going to ask you for parentheses, and then you type in this order, N, comma, P, comma, 5. Now, in newer calculators, it's going to say trials, and then it's going to say probability, and then it's going to say, I don't know, X trials or something like that. And you type in those numbers, and it will give you 1272. Okay? So, Ms. Carver, right quick, can you see both of the screens? The PowerPoint on the left and the document cam on the right? I'm waiting on her. She's typing. And also, since okay, I'm thinking it may be a lot of traffic. You know, if you think about it, it's not just South Carolina and Tri-County Tech doing this. We've got the whole nation doing this. So I think we probably need to be thankful of what we've got. All right? Okay, there's the alarm, but I'm going to go ahead and finish this problem so you can do homework problems. All right, here's the next problem. Okay, I'm going to blow it up so you can see it. I don't know who that is calling. They don't need to be calling me while I'm teaching. Okay, this one says, according to the Experian Automotive 35, the same question, blah, blah, blah. What is the probability that less than 4? Boom, less than 4. So I'm going to go ahead and minimize this, and I'm going to show you why if you get confused, if you get confused, that's why the number line is so important. Okay? The number line is so important. So, we still got n is equal to 20. P is equal to 0.35. And x is equal to, and I'm going to put right here, I'm going to put less than 4. Less than 4. So you draw your number line. You know this is 0, 1, 2, 3, 4, 5, 6, ... to 20. Less than 4 does not include 4. Does not include 4. Okay? So therefore, you're only going to do 0, 1, 2, 3. So we're going to type in second vars binomial CDF, because I want a cumulative probability from 0 to 3. And I'm going to type in 20.35 and 3. And that should give you this probability of all three of these added up of 0.0444. And that's called a cumulative probability. And then the last thing would be, and I'm going to do this in blue, what if I asked you for at least 4? At least 4 means what? From 4 all the way up to 20. Now you can do 4, NP4 plus NP5 plus NP6 plus NP7 and all the way up to 20. Or you can do 1 minus what? 1 minus this orange. 1 minus the orange, because the orange is this side and you need the blue side. So you can do 1 minus 0.0444, which is the complement, and that's equal to, and they're going to give you this one right here. Let me go ahead and, there it is, 0.9556. So there's the three type questions you would get. You would get, I'm sorry. Here's the three type questions. You would get exactly, you would get less than, and you would get greater than, or at least. You would get greater than. And those are the three type questions that you would get in this first section of 6.2. Okay, I'm going to shut down the recording and pray.